recording this and see if I can get the sound. I haven't had much luck at picking up the audio. In order to get the sound, I'm probably going to have that background beeping. If it bothers you too much, let me know.
Okay.
But I think that's the only way this recording is going to work. I'll see here. All right. Maybe if I turn it down a little bit, that will help. Okay. All right. What do you got today?
I have a review worksheet for my test on Friday.
Okay.
So it has a lot of things, but okay. Here are some that I need help with. Let's see what it is. Okay. So one of them says 56 to the power of 1/3 over 7 to the power of 1/3.
Okay. If we have the same base, we can manipulate the exponents. Or, if we have the same exponent and different base, then there's always this rule in play. In other words, in this case, I can take 56 divided by 7 and take that to the 1/3 power. That's what that's equal to. And what's 56 divided by 7?
Right. The power of 1/3. So 2.
Uh-huh.
Okay. I was trying to do this at lunch today, and now I forgot all my questions that I had. Okay. Another one says 3 to the power of 1/7 over 3 minus 6/7 to the power of -6/7. Sorry.
Here we have the same base, different exponents. Division is happening, so what do we do with the exponents?
You simplify them?
Subtract. Always remember that we're going to do one mathematical step less than what's happening. In other words, when we're dividing the same base, we're going to subtract the exponents. If we are multiplying the same base, we add the exponents. So multiplication equals addition, one level less. Division equals subtraction, one level less. And exponentiation equals multiplication, one level less.
All right. Okay.
Okay? So this is obviously 7/7. So that's equal to 3 to the 1. Or 3.
Okay.
Now just let me back up 1 second here. Whenever you see a negative exponent, you can always put it on the other side of the fraction bar and change the sign on the exponent. In other words, this is the same thing as doesn't matter whether it's in the numerator or the denominator. If it's negative, you can move it to the other side. Or if you move it to the other side of the fraction bar, you have to change its sign. Either way. But, I mean, I know a lot of people know that that is 1/3 to the 1/7. But not everybody would know that that is the same as 3 to the 1/7.
This is a review, I guess, but it
Okay.
says the cube of 27 times x to the power of 9 times y to the power of 5 times z to the power of 4.
Okay.
You just split out, right?
Yeah. Let's do a first step here, which I kind of like for all of these, but you may prefer something different. But this is what I always would do. Now you can apply this 1/3 to every term here. So I can separate it into 27 to the 1/3, x, well, 9 to the 1/3 is the same as x cubed, y to the 5/3, z to the 4/3. Now I simplify. What's 27 to the 1/3?
That is 3.
X cubed is already simplified. But y to the 5/3 is equal to y times y to the 2/3, right?
Yeah.
So this y I can pull out and leave y to the 2/3 behind. So there's a y, and here's a y to the 2/3. Now I'll show you why we did that, as opposed to leaving it as y to the 5/3. And what can I do with z?
You can make it z to the z squared.
Well, z to the 4/3 is equal to z times z to the 1/3. In other words, I'm always looking to pull out the whole variable there. And I'll show you why. Okay? So we're not quite done. Now, since the problem was given to us in this format, I want to put it back in that format when I give it back to them. So what I have is, make sure you understand how I get this. In other words, I've pulled out that, and that, and put it in front. And then I've taken this and this and put it back in the cube root. Because of that, they're both cube roots, only the y is the cube root squared. So I write it like this. And now that's going to be the answer that you're going to see if it's a multiple choice test, or even if it isn't. If you have to give an answer, this is the best way to give it. At least if it was given to you this way. If it was given to you this way here, then probably this might be sufficient. Well, you'd want to always reduce that to 3. But whether you'd want to pull out the y and the z or not, I'm not sure. But usually it's given to you like that. It's usually given to you with the radical sign. Your problem had the radical sign, right?
Yeah.
Yeah. So you want to give it back with the radical sign, and that means you have to pull out part of that y, the y that was to the 5/3, you need to pull it out as a y, and then a y to the 2/3 left. understand that this here is the same as y to the 2/3 times z to the 1/3.
Yeah.
Okay.
Okay. My next problem says that I've done better. It's irrelevant to anything. Okay. Oh, okay. I don't know how you would simplify this one. So it says 4 times the square root of 2 minus the square root of 8.
Okay. Well, we know that that's impossible to do. We can't simplify that because this is an apple and that's an orange. However, they're asking us to subtract 4 apples and this thing over here, which may or may not be an apple. Can we simplify root 8?
No. Well, yes, you could do 2 roots.
Oh, that's pretty good because now we have 4 apples minus 2 apples.
Oh, excellent. Okay.
So you've got to get the radical to be the same before you can add or subtract them. Multiplying and dividing is a different story.
Yeah.
If I'm multiplying those two, I can do it easily. That's the root 16, which is equal to 4. Adding and subtracting, remember, is always harder than multiplying and dividing.
Okay. So I'm trying to find problems.
Yeah, no, why don't you go through your whole review, picking out the toughest ones, and then if we have 10 minutes left over, go back to the beginning, and let's go through the second toughest ones.
Oh, okay, so what our teacher does is we have a group test a few days before our regular test.
Uh-huh.
And that was today, so I worked with a couple other students to take it.
Okay.
And it went really well, except for there were a couple problems like these, which kind of tripped us up a little bit.
Okay.
So one of them says the square root of 3x plus 13 is equal to x plus 5. And then I want you to solve it first.
Okay. Whenever I'm solving an equation that has a radical sign in it, this 13 was under the radical sign?
Yeah.
Okay. Whenever I'm solving an equation with a radical sign, my first goal is to isolate the radical sign and everything under it. Well, once I get that done, then all I have to do is square both sides. So this came already isolated. I don't have to do anything to isolate the radical sign. So first step, square both sides. What's the left side squared?
The left side would be, 3x plus 15, but then the right side you have to square.
Right. Get so you know how to FOIL that based on this. I may or may not have mentioned this before, but I'm going to re-mention it because it's so important. Especially when you go take your SATs and ACTs. Now, obviously, I could do either of these steps by foiling it, but it takes a long time to foil. So, try to get to where when you see an a plus b quantity squared, or an x plus 5 squared, you can immediately answer that. So how would we do it based on this?
Well, it would be x squared minus...
No, it's this one here.
Plus?
It's an x plus It's an a plus b squared. Notice the only difference between a plus b squared and a minus b squared is the sign on the middle term. It's the only difference.
So then it would be plus 10x squared, or 10x.
There you go.
45.
Being able to do that in one step is going to save you a lot of seconds on the ACT exam and just in doing higher math in general. Only because you have to do it so much. And in other words, if I was squaring the following, let me give you one. Square that. And let's make it plus.
So it would be, okay, x to the power of 4 plus 4x squared times y plus 4y squared.
Perfect. That's what you want to be able to do, is expand the binomial to square. In other words, you want to be able to square any kind of a binomial term.
Okay.
Now, how do I solve this?
You are going to want to subtract everything from the left-hand side.
Okay?
Is that right?
Yeah. In other words, the first thing you want to notice is that we're looking at a quadratic. And we solve quadratics by putting everything on one side and 0 on the other. So it's important to recognize that you're looking at a quadratic and that that's what we want to do. In other words, a lot of equations, we gather all the x terms on one side and the numbers on the other. If it's a linear function, that's the way we solve it. But if it's a quadratic function, we don't solve it like that. We solve quadratics by putting everything on one side, 0 on the other. So let's do that. We also want to maintain the positive coefficient in front of the x squared. So I don't really want to bring everything on the right over to the left. So I'll take everything on the left and move it to the right. So what does that give me?
0 is equal to x squared plus 13x
7x.
plus 38.
I have to subtract both of those from the right side.
I did that all weird. Okay.
Plus 12.
Yeah.
Always remember you have to do the opposite of what's being done. 13 was being added, so I have to subtract it. 3x was being added, I have to subtract. Okay. Now how do I solve this?
Quadratic formula?
Always try to factor it first, because most of the time, especially in your new algebra class, it's not going to call for the quadratic formula. So if you always go into the quadratic formula, you're going to take more time than you would normally take. This factors actually pretty easily. What's the next thing we do?
The next piece I'm going to want to do is do the little square thing, and so you'll get 3 and 4. Plus 3 plus 4.
Okay. The next thing I do, now I know that everybody has their own method, but I examine the sign on the 12. It's plus. Therefore, I know that signs have to be the same, and they have to be whatever the middle term has. So it has to be plus plus. And now I can say factors of 12 that add to the number 7. If that's all equal to 0, then what's my solution?
Would be negative 4 and negative 3?
Yeah. Now, there are 3 types of equations that tend to produce extraneous solutions. One of them is radical signs. The other is absolute value. and the third is logarithmic. This almost always gives you an extraneous solution. So with logarithmic equations, you definitely want to check your solutions, but definitely with either of these also, since this was a radical, we better check it. So let's check x equals minus 3 and x equals minus 4. Minus 3 gives what?
It will give you 22 is equal to x is equal to 8. No, because you have minus 3. Never mind. So it will give you 9 plus 13.
Minus 9 plus 13.
Sorry, minus 9 plus 13 is different because that gives you 4, right?
Yeah, square root of 4.
2, so that's still not equal to 8.
Well,
Okay.
minus 3.
3. Yeah, so minus 3 works.
Okay, so minus 3 works. How about minus 4?
And so minus 12 would give you the square root of 1, which would be 1. And then negative 4 5 is negative 1.
It's positive 1.
Or, sorry.
Negative 4 plus 5 is positive 1. So both of them work. But you will frequently find that when you have an equation that had a radical sign in it, that one of these solutions is bogus, or what they call extraneous. Okay. What else you got?
Alright, maybe another one like that.
Okay.
Kind of different though. 2x, oh, in parentheses, 2x minus 1, end parentheses, to the power of 1/5 plus 2 is equal to 3.
Okay. This is the same as having a radical.
Okay.
So my rules are going to be the same. I got to isolate that radical. What's the first step?
You subtract now.
Okay.
And then you're going to want to multiply?
Not multiply.
Or
Exponentiate.
By 5. Power of 5.
What's that leave on the left side of this equation?
Okay. And so that would give you 2x plus minus 1. And then that would be 1. And then you add 1 and divide by 2. So I guess
X equals 1. And just probably not necessary to check it because we only came up with one solution. I'm not sure I've ever seen a problem. I suppose I have, but it's rare when one solution is extraneous. Usually it's when you come up with two solutions that you find extraneous. So I wouldn't be that feeling like I had to check this, but if I do, I get 2 times 1 minus 1 is 1, to the 1/5 is 1, plus 2 is 3. So it works.
Okay.
And maybe time for one more?
Yeah, okay. There's one that says 2x to the power of 3/4 plus 7 is equal to 23.
And the entire 2x was in parentheses?
Yeah.
Okay.
Actually, no. There was no parentheses, so it's just the x that's being
Okay.
raised.
First step?
Okay. The first step would be, sorry, David's doing that. Okay. Would be to subtract 7. Then you would get 2x 3/4 is equal to
Okay.
X to the 4th equals 8. And then exponentiate to 4 over 3.
Yeah. That's the key step right there.
Yeah. And then the question I had with this one really is, would you cube it or take the cube root first?
Yes. Always do the denominator first.
Okay.
Why? Because the cube root of 8 is 2, and 2 to the 4th is 16. I didn't have to deal with a number bigger than 16. If I were to have taken 8 to the 4th power first, well, that's like 64 squared. That's a gigantic number. And then I would have had to take the cube root of that big number. It would have still been 16, but I would have needed a calculator. And almost every problem you're going to run into that has a fractional exponent like this, do the denominator first, the root first. Keeps all your numbers small, and they're not going to give you a problem where the cube root of 8 is not a whole number. In other words, they would never ask you what this is, because the cube root of 7 is not a whole number. So when you have problems that have fractional exponents, always expect this root of this number to be a whole number. Okay. Does that do it? You have any last questions or anything?
No, I think I'm good.
Okay. Okay. So I'll talk to you Monday at 5:45.
Okay. Thank you.
All right. Bye-bye, Sarah.